This is a Zener diode symbol. Take a look at this bar. For ordinary PN junction diode, this bar will simply a straight line. This line indicates very little current can flow in this direction. The diode is reverse biased if the current try to go in this way. For ordinary PN junction diode, if the reverse bias voltage is higher than the breakdown voltage, the diode can be damaged and can be overheated and damaged. But for Zener diode, it is purposely designed to operate in the reverse breakdown region. Once enter into this breakdown region, the voltage across the Zener is almost a constant. We call it Zener voltage, labeled as Vz. The Zener voltage or breakdown voltage is set carefully by controlling the doping level during manufacturing. This is the VI curve of a normal PN junction diode, which is often used as a rectifier diode. What is rectified will be discussed in other unit. Let's focus on this VI curve. The normal operating regions of an ordinary PN junction diode are this forward bias region and this reverse bias region. We shouldn't bias the diode to the reverse breakdown region because that can damage an ordinary PN junction diode. But for Zener diode is different. It is heavily doped, so it can be biased in the breakdown region, specifically call it Zener breakdown region, and it won't be damaged. So we can keep its voltage across the Zener diode to be more or less a constant, the Zener voltage. For the forward biasing side, the two VI curves are similar. Let's further discuss the reverse bias regions of a Zener diode. When we increase the reverse bias voltage slightly, the current go through the Zener is insignificant, very small. Further increase the reverse bias voltage, the current go through the Zener can increase significantly, while the voltage across the Zener is more or less a constant. This point we call it a test point. The manufacturer will specify the test current, called IZT, Zener test current. Corresponding to this current are the VZT, Zener test voltage. The datasheet, the Zener voltage, is usually given as equal to this VZT. The test condition voltage is the Zener voltage. The normal operating region of a Zener is the Zener breakdown region, this region. The current, the minimum current expecting to go into the Zener is minimum this value, IZK. K stands for Ni, Zener Ni current. The maximum current supposed to go into the Zener is IZM, Zener maximum current. If the reverse bias voltage is set too high, the current go through the Zener will be higher than this IZM. In that situation, the Zener will enter to the avalanche breakdown region, and the Zener diode can get damaged. So avoid this region. This is a simple Zener biasing circuit. R2 is the load. It's supposed to work with a specific voltage. So we choose a Zener that offers that voltage for this load. R1 is adjusted such that the current going through the Zener is equal to the Zener test current. So once have that current going in, the voltage across the Zener will be equal to the VZT or the Vz. So it's the required voltage.